Thank you everybody for attending this .NET Peterborough Meetup. It's obviously our second virtual presentation. And the meetup itself has been going for 18 months, and it's great to see some new faces and some regulars as well. This is the agenda for the evening. So we're starting now at 7:10. So we'll go through the meeting rules just quickly, future presentation topics, and then a suggested next meetup date. We would have a presenter lined up for that one. Then we'll hand over to Albert to present ongoing serverless with Azure Functions, and he'll take us through what he's been doing there. Then I've put in a break at 8:20 for 10 minutes, when we'll have a Q&A session and open up discussion. Whether or not we keep those timings or not, I don't really know. Albert said he's got quite a few slides to go through, and then also there might even be a time for a coding dojo and all sorts of things going on. So we'll just play it by ear, Albert, if that's all right, and everyone.
Yeah, that's all right.
So the meeting rules, looking to respect each other and everybody's ideas. If you could please go on mute during presentations. That said, there might be opportunities for questions and answers during the presentation, but Albert has asked if any questions there could be towards the end. If you disagree with what's been said, please challenge politely at the end of the presentation. These meetings aren't for recruitment purposes. Zero tolerance towards discrimination of any kind, and zero tolerance towards violent, dangerous or criminal behaviour, although I don't know how quite you can do violent behaviour over a virtual meeting, but there we go. So the future presentation topics, this is actually dates back from the previous list 18 months ago from the first .NET Meetup, but we've still got F# on here, Signal R, Visual Studio 2019, using the command line tools, and I've put on there .NET 5. Obviously .NET 5 is looking to be released in November, so there might be opportunities there for people to present on those subjects. And towards the end of this this evening, when we get to the Q&A and discussion section, if anybody's got any other ideas or would like to present on future topics, then please let me know. So the next .NET Meetup date we've got down, if you can put it into calendars, it'll be the Tuesday the 17th of November, and Abel Agorigor will be doing effectively a part 2 of his presentation from earlier in the year, so building an Android app using Xamarin for Visual Studio.
Cool. Hi everyone, evening. Hope you have a lovely day. It's Tuesday evening. My name is Albert Sitebro, and I'm a technical lead over at the Agile group. That is my role, but I'm a .NET software engineer by trade, if that's what they call it. So today I'm going to be talking briefly about going serverless. It's funny actually, because after the last meetup, we were thinking about what would be the next thing to talk about, and then we looked at the list of topics that have been suggested, and then I started waffling on about what a talk like that would sort of be like, and not realizing that I was actually talking myself into doing the presentation. So here it is. Hopefully it goes well. So here is a bit of background of what I'll be talking about. Ignore the title. I don't know how that got there. Basically, I'll be talking about background about some stuff I've done with functions previously. I'll talk about a high-level view of serverless. Talk briefly about Azure Functions, the Azure Functions core tools, and then we'll have some questions.
Albert, just quickly, some of the folks are saying there's a bit of background noise or some fuzziness on your microphone.
Oh, okay. I'll lift the microphone away so that hopefully, is that better?
Yeah, I think that's much better now. Yeah.
Okay. All right. I'll just keep it stable. Right. So background, how did this all start? So a couple of years ago, I acquired an Amazon Echo device, and as a developer, I thought, okay, how does this thing work? I will go online and see what I can do, and then I decided to create an Alexa skill. And um, after doing the whole hello world shenanigans, I then thought, okay, what's the next thing I could do? I then built a service that would tell Chuck Norris jokes. So basically, I would bring the device to work on Fridays, and then do that whole thing of Alexa, ask Helen what would tell us a fact about Chuck Norris, and then it would just go to an API, which was basically a JSON file that compiled with all sorts of Chuck Norris facts from the internet, and the device would say it out. Then after that, I was part of a team during one of our hackathons, our innovation day, where we built an Alexa skill which allowed customers, which was simulating a scenario where customers would be able to self-serve on their insurance policies without having to ring the customer service call center. It was a brilliant experience about doing these things and learning them. And the most enjoyable part of it was how quickly we were able to get up and running, how quickly we were able to get our code into an environment to be tested. And then in that situation, obviously we had to do something quickly, and so we had to use Azure Functions. Now, it especially meant that using Azure Functions, we weren't dealing with the infrastructure side of things. We didn't have to worry about who could make virtual machines or servers available to us, the infrastructure side of things, working with DevOps. The only one thing that we had to grapple with was firewall rules to allow traffic through those services, which was quite minimal because most of the traffic was between the Alexa service and the Azure Function service, which is all in the cloud. So essentially, we built a serverless set of serverless applications. Now, looking at serverless from the high level, it starts from how far cloud computing has come from the very first cloud services that came as an alternative to on-premises. Obviously, the first set of cloud services offered networking, virtual machines, firewalls, things like that, such that you could spin up instances of virtual machines to host your servers as an alternative to acquiring and maintaining servers on premise. So imagine if you had to write an application as a developer that did one thing, you had to rely on the business making a decision to determine whether they've got the budget to buy the server to host your code. Then we'll need a team of infrastructure guys and server administrators that will manage that server and ensure that all updates are installed and ready for your application to run and scale. Then cloud came along, brought in infrastructure as a service, platform as a service. So platform as a service abstracted away the virtual machines. So you didn't need to worry about virtual machines, just build your application and then deploy it into one of the platforms, depending on the language you're working with, whether it was .NET, Node.js, or Java. And then the cloud service will host that for you. And now we've come to a point where we have serverless, which essentially allows us, puts us in a unique position of being able to build applications that are cloud native from the ground up. So it now brings developers closer to getting their application logic out there in the wild, without having to worry about a lot of the red tape that comes along with trying to get your application out there. So looking back from when it all began, if as a developer you wanted to build and test applications locally from home, you probably start to worry about, okay, do I need to buy a microserver or a PC that will run this and that operating system and platform, I need to install a virtual machine. Oh, now these cloud services are hosting virtual machines for me. I don't need to worry about that. And now we've got to the point where all you need to do is write your code, get it deployed, and it will just run, which then means you can write functions that will execute one task based on an event that triggers it, and then that is running. You don't need to worry about what platform it's running on. You don't need to worry about what is maintaining, as long as the SLAs are in place and the availability is high. Jobs are good. So, of course, when the whole paradigm of serverless came around, it was the mindset was, oh, okay, we're not looking at servers. There are no servers. Well, there are no servers to the extent of, as developers, we're not building and maintaining the servers. We don't have to rely on a dedicated team of IT ops guys to help us maintain them. It's all managed out of the box, and we only pay for what we use. So it's basically more like less server and more and not no server at all, because as we know, everything runs on the server somewhere. Like someone said, the cloud is essentially someone else's computer. So as I said earlier on, it brings the developer closer to business logic, being able to deploy your application and insulating you away from the infrastructure concerns. You're not worrying about server, patching the server, running updates, antivirus, all that, so you can focus on your code. Then comes in Azure Functions. Obviously, for serverless computing, what makes serverless computing tick is the availability of functions. Azure is one example, as you well know. Other examples are Google Cloud's Google Run. You've got AWS Lambdas, and Azure Functions is just a flavor of that. They all do pretty much similar thing. They take your code, spin up a runtime, spin up an environment to host that code, and then execute it when an event triggers it. Now, the reason Azure Functions is quite there's a great affinity from .NET developers is obviously because of Microsoft's .NET provision. And the brilliant thing about Azure Functions is that it's built to work especially well with .NET Core. .NET Core really lends itself well for running with functions. Now, Azure Functions, some brilliant things that it brings to developers is the ability to develop and test locally. So essentially, you don't have to deploy it to an environment to test it. You can run it locally on your local dev machine, whether you're doing it on Windows or Mac or Linux, whether you're using Visual Studio, VS Code, or even CLI tools. You're able to run the function runtime locally on your machine. It also means that you can debug your code and make sure everything works well before it goes live. Another added benefit is the fact that you are able to connect to live Azure services. So if you're writing a function that talks to, say, Azure Storage or Azure Cosmos DB, you're able to connect to those services while you're running locally. particularly with .NET Core especially, and .NET Standard as a whole, soon to be .NET 5, you have a variety of tools available to you to work with Azure Functions. So you can use VS Code, as I used in this case because I'm on a Linux machine. You can use the command line if that's what you prefer. And another thing that's brilliant with this, as you would imagine, is also the case with most cloud providers. There is a certain level of um, free executions per month. So they provide 1 million free executions per month. So if you want to do some development, you have an allowance of 1 million calls to your function when it goes live. And they have a micro billing payment plan. So you basically pay for the execution of the function. Now, when you're building functions, this image here is an example of how you could use functions to essentially host a web API. So when you would normally do with web API, you would set up an MVC, ASP.NET MVC application that hosts web API endpoints. And then you have controllers and actions with those controllers that then receive HTTP requests and execute some logic and then return a response. Now, with the functions, all you're expecting is a trigger. So if you're building a web API type application, what you'll be working with will be an HTTP trigger. So the HTTP request is the trigger or event that triggers the function. Now, in this diagram, I have a checkout API, back office processes, payment processing, order fulfillment, and a database in the background. Now, these ones, though the checkout API is called an API, it's actually a function that does one thing and one thing only. So it receives the request for checkout containing the payload that has the order details, sends those order details to a database. When the database receives the order details and updates those details in its records, it will fire off a trigger to say there's been a change. Now that trigger then goes out to any function that is expecting that trigger. It's sort of similar to what you can do with message queues or pub/sub type scenarios. It's something similar to that. So the checkout function receives the HTTP trigger, receives the payload, sends it to the database. The database updates the record, and then sends out a change trigger. Now, these other functions below will receive that trigger and then perform their particular activity based on the logic that's in there. Now, looking at the components of a function, I've already mentioned the trigger. So you have your function. We all know what a function is. It's a block of executable code that receives an input, processes, and returns an output. In that, guys, we have the concept of triggers, inputs and output, triggers and bindings, which are essentially the parameters that will go into the function which your code then executes. So the components of, just as we have with regular .NET applications, we have the idea of the function app. So the function app is just your plain old class library. It's your CS project, and it gets compiled into a DLL, and it's that DLL that gets deployed to the Azure Functions runtime. Each function app, just like every class library, can contain one or more functions. The function is represented as a static class with a run method within it. Now, Now, you could have multiple functions running in it and label them with function names, but just to keep things simple and clean, the convention that the functions runtime looks at is the name of the class or the attribute function name is part of the path, especially if you're imagining an HTTP triggered function would have the base address /API / the name of the function that is to be executed, and the class is static and the method is static. Now, it doesn't necessarily have to be exactly an action result. This particular function is an HTTP triggered function, so essentially it's an HTTP endpoint. Now, it receives a single trigger. Now, every function method expects one trigger, one and only one trigger. It can only receive one trigger. In this case, we have an HTTP trigger, which is essentially the HTTP request object. And for this particular trigger, we have, if you see there, you'll see an authorization level function. There's actually 3 different authorization levels. One is anonymous, which means you don't need authorization to hit that endpoint. Then we have the function authorization, which is there is a key that is generated, and that key has to be appended to every request to that particular function. And then you have the administrator authorization level, which is essentially a master key that is required for all the functions within that function now. As I mentioned, every function receives one trigger, and the trigger is essentially an event. Here are some examples of different triggers that that Azure Functions expect. So we've got the storage type triggers, which essentially is linked to any activity that happens on blob storage. So, for instance, you insert an object into blob storage, or you update a record or delete a record. That change event will send a trigger to that particular function that is expecting the trigger, and it's the same thing with all the other triggers there. So the Cosmos DB, send grid, and similar negotiate trigger. I mentioned bindings, and bindings are parameters that provide data that allows you to link with other Azure services. So in this example that I have here, I have a Cosmos DB that this particular function is supposed to talk to, and the attribute above is the input binding, because it has the particular parameter there does not have an output prefix, and the particular type is treated as an input object. Now, the Iasync Collector is a type that is used by Azure Functions to handle output binding. So if, for instance, you're dealing with records in the database and you want to add, say you receive the records. So in this example, I'm expecting to receive the records from the database, select a particular item from that collection, make a change to that item, and then update the record in the database. Now, I can't use the IEnumerable because that's the input binding. What I will do is add the new version of the object into the Iasync Collector object, and then the functions runtime will pick that up and update whatever target that is meant for. So Azure Functions Core Tools is a tool that allows you to do things with Azure, where you can spin up, maintain, and deploy environments when you need them without having to use GUI tools. So this can be used for scenarios like when you're doing DevOps type tasks and you want to script the provisioning as well as tearing down of environments and applications. You can use the Azure Functions core tools to do that. Essentially, it's built on top of the Azure CLI and provides you with specific commands that essentially run these CLI commands to manage your projects for you. Anyone have any questions so far?
I've got a question, Albert.
Yeah.
So I wasn't quite clear why you had two Cosmos DB attributes in that as function parameters again. Would you mind just yeah, that one there? Well, I didn't quite follow what you were saying there. If you wouldn't mind just clarifying that again, is that okay?
Okay. Yeah, that's good. So essentially, the function, as I mentioned earlier, expects parameters as most functions do. The first parameter it receives is the trigger. The trigger is the event, and then all the parameters that follow after that are bindings. Now, a binding is a parameter, is a type of parameter that allows you to interact with other Azure services. So in this particular example, the Cosmos DB attribute tells the function that it needs to interact with Cosmos DB for data. The subjects in IEnumerable is a collection of subject records that the runtime will query from the Cosmos DB database on behalf of your code. So as you see in the properties that are passed into that Cosmos DB attribute, you have the database name, the name of the collection, because it's a document database. You have a connection string. That connection string is held in the app settings JSON file. And then you have a SQL query. Now, Cosmos DB uses both C# based CDK SDK commands, and also uses SQL commands for querying data. So essentially what that does is it queries at the time the function is triggered, it queries the Cosmos DB database, gets the data that is requested in that query, and then it passes so basically deserializes the result into that IEnumerable type subject. Once that comes in, that then is available for your logic, for your code. So you can do things like enumerate through that collection, and then build a list that you return to your client, or if return to the page, return to the requesting endpoint, or you can do updates on a particular item within that collection. Now, in the case where you do updates in a particular collection, updates of an item in the collection, what then happens is, because you're not returning, the return that the function does is to the trigger that is calling it. So the function could be void, in which case it's not returning anything, or it could return something like an action result if it's an HTTP triggered function. Now, what happens with the second Cosmos DB attribute? It does the same thing. It calls the database, calls the collection using the connection string, and then any item we add into the subjects out collection, that item is then sent back to the database to update the records in there. Now, this is just this example, but it was just to illustrate what the bindings do. So you have input bindings and you have output bindings. Essentially parameters that allow your function to interact with other Azure services. This example uses Cosmos DB, and another example could use Azure storage tables or Azure storage queues, or even service bus. So if, for instance, your function was created to pick up items from a message queue and process them, you would have an input binding with service bus as the attribute, and then put in your properties to define the connection to that particular service bus queue.
Great, thanks, Albert.
That. Yeah. Any other questions? Okay, in the absence of any questions, there's not a lot of slides here. It's just a brief overview, so I can take some time to walk you through some code that I put together. Now, it may not all work because for some reason the Cosmos DB connection was playing up a bit. So I will just pause this slide for a moment and bring up Visual Studio Code. So can you still see what I'm presenting?
Would you be able to perhaps zoom in a couple of notches? Would that be okay?
What's that?
Would you be able to zoom in just a little bit on the code there?
Yeah, let me do that.
Cheers.
How's that? Zoom in, or should I go further?
I think that's fine.
Okay.
Thank you.
All right. So let me close all this. So essentially, the quickest way to work with Azure Functions or Azure anything in VS Code is to have the Azure extension installed. So essentially, you've got the subscription available once you're logged in, and you should be able to do things like create and manage your functions. So this is a function I created earlier, and if I go into send vote. This particular example is just a random voting polling app that I tried to put together just to demonstrate this. So essentially, each endpoint that a client will call will route straight to a function and execute that. So this particular one receives a request to send a vote. So presumably, in this case, a user loads the web page of the app, and then there's a list of options to choose, and then they select the option and then hit send. That comes into the function via the HTTP trigger. My authorization level is at the function level. So when this function gets deployed to Azure, it usually has a signature appended, a signature code appended to the URL. That's my trigger, and this is the binding that I have included here. And in this case, it's an output binding. This is the iCollector. In the screenshot I had in the slide, it was an Iasync Collector that was used, obviously because it's an alternative to the basic iCollector. So the collector is basically a collection type that is used to pick up data that can be passed on from the function to any other Azure service. So my Azure Web Job Storage, that is my storage account, which is configured in the app settings JSON file. And then this is the name of the queue that I want to send the data to. So what then happens is I do a basic check. It's just a basic, simple execution. I then add that particular request body into the message queue, and then return a response to the client. What this then does is it adds it to the message queue, and that code then gets received in the message queue. I have this other function that I created called save vote, and rather than an HTTP trigger, it has a queue trigger as the input. So essentially, what this function is doing is listening to the queue to see if there's any messages in there that it can pick up and send across. So now this function receives the trigger, and then I've added the Cosmos DB binding. And what I've done here is, because I'm not using the iCollector or Iasync Collector, I'm defining the document as an output referenced parameter, which means that this is going to be made available to the other Azure, the target Azure service, after the function has been executed. So essentially, I received the parameter in the trigger, which is a vote object. I set the ID on the object, then I assign the vote object into the document, and then come out of the function. What then happens is that particular document is then passed on to Cosmos DB to insert it into a collection. These two functions are basically GET request functions. This one is using the document client object rather than using a query. And what it tries to do is creates a URL, calls the database, and tries to get a list of results. For some reason, it's not playing ball for whatever reason. I keep getting 500 errors. So when I run the demo and you see errors, that's the reason. So essentially, the Cosmos DB attribute is the input binding in this case. And then what then happens is, in my code, I then access the document client and use that to extract the results of the data I need, and then return that in the response to the client. And it's the same thing here, exactly the same behavior that's expected. The difference is the other one is a filtered query. This particular one has, so this is where I've got the example. So this is where I've got the two bindings. So we've got the Cosmos DB input binding, and we've got the output binding. So what happens here is we receive the request, pass the request into a data object, we get the ID, then we create the URL for that request. We send a request using the subjects in binding, get that particular object. If it's null, we return the status of 404. Otherwise, we change the status of that particular object. Then we add the new version of that object into the add async method, which then makes updates this collection. That is then passed on to the Cosmos DB service, and then updates the database that's been defined in the attribute. If I wanted to create another function, I could just create a class, a static class, and add the attributes, or using the tool, if I just go Shift-P, create a function, and then I can choose which particular trigger I'm targeting. So if I opted to go for a service bus queue trigger, demo, It would create that file for me and just gives me a basic representation of that. So what then happens is I can then interact. So this particular function is expecting the service bus trigger. So basically this function is here to handle request messages from a queue. So if this particular queue had messages in it, they will then be fired off to this function. This function will need to handle it. Let me see if I can run this demo. Hopefully it works. Just going to quickly launch Postman. Hopefully this doesn't freeze up because sometimes it does that at runtime. Let me find out what's going wrong there. This one. While I wait for this to run, does anyone have any other questions?
I've got a question. That's
Yep.
okay. If I've understood things correctly, your code just sits there, not in memory, until the first trigger happens, like first HTTP request comes in, and then it's brought into memory, executes, and then finishes its work and hangs around in memory for a little bit, but you can't rely on it staying there for ages, and then eventually gets swapped out again. Assuming that's basically correct.
Yeah.
Have you noticed much difference in
Yes,
the latest?
that is essentially Yeah, that's a good question. I've experienced that, especially when working on the pilots I did in the past. So the stuff we did with Alexa, the Azure functions that we set up. So the basic Azure functions they have, like the ones on the consumption plan, they usually time out just as you described. And then what happens is the first time you send a request after a while, it takes that time. So you definitely see that lag as it tries to spin up an environment and spin up the runtime in order to execute that function. So some folks have suggested in the past that in such situation, if you're using that type of approach, what you can do is have at certain times just send a random request just to sort of warm up request, just to spin it back up, because they will, these particular ones, especially the ones on the consumption plan, if you're not on the dedicated plan, I think you will have to wait for the first request if it's gone down. But at the point where it starts receiving the request, it will stay up for that duration. And then once it has a timer, I think even in some cases, my local runtime, when I run it locally, sometimes the version I'm running in the console will just turn off after some minutes and just stop, and then I have to spin it back up again.
Could you give us an idea of the difference in the latencies, please, between the cold and the warm versions?
I haven't got that number off the top of my head. I'm sorry about that.
That's okay. I mean, just so I assume for the warm version, it's pretty much as fast as your code can run with a little bit of overhead due to the plumbing.
Yeah.
It's more the how long does it take to spin up from cold? How much extra does that give you? So I'm not saying how quickly does your code run. The thing I'm more interested in is how long does it take to go from cold to warm?
Yeah, the first record usually takes a few seconds, but I don't have the specific number. I can find that out certainly.
Okay, no, that was the accuracy I was after. It's seconds rather than minutes or tens of minutes.
Yeah. Oh, it's definitely more seconds than minutes. The experience I've had, it didn't take a minute. It would take seconds for the first request, and then the other requests will come through quickly.
Thank you.
Let's see if this will work.
I have a question, Albert. Yeah, in a similar sort of vein to the question that Bob asked. Is there sort of a polling service that is out of the box with Azure Functions, do you know, to sort of keep your service warmed up, as opposed to letting it go cold and having to effectively restart it on the next request that comes in?
Yeah, Azure Functions have multiple plans. Let me confirm that for you. I have the image with me. Hopefully you can see this image, and I want to zoom in a bit. So let me see if this will run. So this is the send vote request. So I just have a basic JSON object that I will send for. Hopefully this works. Okay, so let me do something else. Just so if I go into Cosmos DB or the message queue, you should be able to find it there. Okay, so if I zoom this in, what essentially happened here was when I hit send vote, it sent a request into the function. The function then sent it into the message queue. And then at this point, we had the save vote function getting triggered because a new message was detected on the message queue. Now, if I let me quickly open the message queue, so it's there. Go to my resources. So if I go into, that's my function, my Cosmos DB, and that's my storage. Is it signing out? Oh, okay. So if I come into queues, okay, I'm going to now comment out that function that handles receives this. And execute. Let me delete this. So this was a function app that I created using the Azure Functions core tools, which is built on top of CLI, on top of the Azure CLI. So I'm just going to run these commands. So these commands are basically what's running in here are these lines trying to create the function. So shortly we will have the project folder in here and all the functions in them as well. So I've created each of them as HTTP triggers. So we have the func, new, then the name of the function, and then the template and the language we want to create it in. When they eventually work. Yeah, so at the moment, Graham, what's happening is it's so these functions are creating the function files. They've created the function files. So if you wanted to run a script that just generates all the files that you need, this will help you to do that. Obviously, it will be probably quicker if you did something like this in Visual Studio, build the project, then save it as a template. It's something similar to that. So now that it's built the template and put all the files in there, I've already run these commands. So this command will create a resource group on the Azure account. This command will create a storage account, and then this one will create a function app, which is then linked to the storage account. If I scroll through it, so AZ is Azure CLI command, and we're using function app command to creating one, linking it to the resource group that we just created, giving it a name, selecting the UK South consumption plan location, selecting the .NET runtime, the version 3 for the function runtime, which supports .NET 3.4, .NET Core 3.1, and we have the storage account which was created above. So if I run this in terminal, so now it's completed running that. If I quickly open Azure, and refresh this page, it should include the function instance. So that's my storage. That's the function app. And as part of building a function app, Azure will include application insights, which allows you to do log investigation and even real-time live metrics on your functions to see how they're performing. So if I drill down into that function app, at the moment we have no functions in there because we haven't published our function just yet. So if I go to the functions section, there are no functions at the moment. So if I then execute the publish command, so that's going to start the process. So now it's doing the whole .NET thing of restoring the packages in our project. It will then build the project.
Looks like Albert's got some technical issues. Has it just frozen and crashed to everybody else?
Hello, sorry. It just froze again. The moment I started running the publish, it just decided to crash on me.
Okay, you're back again now, Albert.
Can you hear me now? This is going really well. Can you hear me? Right. Looks like my machine is not playable anymore. It's not happy with trying to run these commands. This is embarrassing. Yeah, it looks like it's not happy to carry on my machine.
Okay, perhaps it might be useful at this point. Has anybody any questions for Albert?
Oh, look, it's only gone on. Cool. It's only gone on created the functions I was trying to run, which is great. I just wanted to quickly mention. So this is the command I ran to publish it. This particular command. Remember in the presentation, I mentioned that when you're trying to run, you can run your functions locally and connect them to Azure services in the cloud. So this particular command, what it does is it will call your resource and then get all the app settings that have been configured in the environment and download a copy of it and place it in the local settings JSON file. Now, this local settings JSON file is ignored by default when you create a function app because the rationale is that this JSON file could contain live credentials, live configuration information, which you don't want to commit in source control. So that file is ignored out of the box. Now, what this command allows me to do is do things like pull down the connection string for the storage account, which then means that I am able to connect to the storage account while working locally. So if I run this command, if my machine doesn't die on me again, hopefully we should have some additional. So that's the storage credentials. So some other more bits of configuration information have come through and made them available for running locally. Now, the reason I put these two packages here is, when I talked about bindings and triggers, according to the Azure documentation, the HTTP trigger and the timer trigger, so the trigger that runs your function on a time basis, those are available out of the box, but all the other triggers and bindings need to be installed as extensions. I think it's the bindings, not the triggers. The bindings need to be installed as extensions. So there are NuGet packages and they usually come named in the format of Microsoft Azure Web Jobs extensions, and then the particular binding you're looking for. And then you can just install that as a package and make that available. You can also install NuGet packages for other libraries. So if, for instance, you wanted to use your function to connect to a MongoDB cluster or any other database cluster or an external service that requires connection via an SDK, you can install that package as long as it's supported by .NET 3.1. It will be supported by the runtime. But obviously, when you're writing your code, you need to consider the performance impact, how long it will run, and how much process resource is required. Azure have set limits on execution of functions to the amount of resource that they set as limits, particularly on the consumption plan, is 1 gig of memory on one core CPU. Now, if your function is running so much so that it's using up that much resource, then potentially you may want to consider splitting it up into maybe 2 or 3 smaller functions that carry out those functions. Or there's another alternative, which is out of the scope of this particular presentation, is using durable functions. So basically, with durable functions, you can create one orchestration function that then manages the input and output of a chained set of functions. So you can have multiple functions that run in parallel or sequentially, and then you have one orchestrating function. It's particularly useful when you're doing batch jobs of large amounts of data, and you want to process them asynchronously without affecting using up too much resource. So you can split up the batch job onto multiple functions and then have one function to monitor the executions of those functions. And I think that's it from me. Apologies for the technical issues. And is there any question?
I've got a couple of extra questions, if that's okay. Can people hear me? Hello, can people hear me? Hello, can people hear me? Is that better? I've got a couple of questions.
I didn't hear what I don't hear what Bob's saying.
Hello, is that better? Can anyone hear me? I'll type my questions into the chat.
Yeah. Yes, I can hear you now.
Oh, fantastic. other than these durable functions, are there tools that help you understand the dependencies between separate functions? It sounds like they're sitting there waiting for an input, and occasionally function A creates the input for function B. So I imagine that some of the hard work is working out the dependencies between functions. So do you get any help with that, or is that something you just need to care for yourself?
As Microsoft always does, usually we know that Microsoft will give tools for developers. You can write code, you can manage things manually, but then they will also wrap that manual hardcore management around with the beautiful GUI tool. So what they've done is they've created something called a product called Logic Apps, which essentially is a sort of visual guide to help you manage your functions, whether you're using the basic functions or using durable functions. So with durable functions, if you have to manage them, you will have to manually keep track of those. But with Logic App, it gives you a visual guide as to how they're all linked together. In fact, let me see, I think in the function interface, the Azure Functions interface is a bit where it shows you how your functions are linked together. I'll just quickly share my screen again. If I go back to my function, where is it? It's this one. So if I picked any of these functions and go to the integration section, so you've got the link that shows you how it's all tied together. What then happens is the Azure Logic app gives you a visual means of building and managing your functions, basically taking the heavy lifting away. So it gives you this visual style. You can design your functions, you know exactly where they are and how they're all linked together. And that is sort of a way that that can help with managing large, complex function applications. But obviously, as we all know, yeah.
Sorry, I've got a second kind of related question, which is how does what you've just shown us compare to Azure Data Factory? When would you use one and the other?
Azure Data Factory.
My understanding is Azure Data Factory is the cloud-native version of SQL Server Integration Services, SSIS.
Okay. Oh, okay. 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 Yeah, I haven't looked at this. It is there'll probably be a way it can be integrated. I don't know if there's bindings. It will probably be through bindings.
Sorry, my question was more not how do they fit together. It was what kind of jobs would you use one tool for, and which kind of jobs would you use a different tool for? They seem to be similar but different tools. I'm interested to know where the boundary is as to what kind of problems should fall to one tool or the other.
Oh, okay, okay, makes sense. Well, as Data Factory, yeah, it's basically based on SSIS. So imagine if you're doing stuff with large amounts of data, so specially built specifically for ETL type transactions. So what you would normally do with your data warehouse versions of SQL Server is what you do with it. Now, if you wanted to split that up and use the function, I suppose it will be a bit overkill to, unless you want to use a function to trigger your ETL processes that already are written within Data Factory. I'm just saying this off the top of my head because if you imagine having your database and then you're connecting to the database and running queries on it, imagine in this instance with your ETL running at scale, because this Data Factory looks like it's according to their notes, is a hybrid data integration service that just simplifies ETL. So basically SSIS at scale. So if you're going to use a function, it's probably a function that will connect to this and start off a set of ETL processes that you've defined within SSIS. Now, I have never used SSIS before. I'm just making an assumption here. I might be completely wrong, but looking at the diagrams they have here and what they've explained the product as, I would imagine where a function would come in would be you have a set, maybe you as a database administrator or data warehouse manager, you want to have functions that will trigger a batch ETL process. So you could have a function that is triggered at a specific time of day or time of night, connects to the Data Factory instance, and then triggers an ETL process. And then once that is done, perhaps if there's any, because I think SQL has triggers as well, whether that those triggers can talk to external Azure services is left to be seen. I'll probably have to do some research into that. But yeah, that's the assumption I'm making at the moment. I hope that helps.
Thanks, Albert. Any more questions for Albert? I take that as no more questions.
Yeah.
So thanks very much, Albert. That was a really good presentation there. Thank you so much. I'd like to thank Albert again. Well done, Albert. It was a good presentation. Obviously, had some very tricky technical issues towards the end there, but it all came good in the end, and it was really, really interesting. I hope I speak correctly.
Yeah, I just wanted to add that. Yeah, I just wanted to add that I will upload, so the source code, the example code, and some of the scripts I put together, I'll put them up on GitHub and share the link in the Meetup channel.
Cool. That'd be good. Thanks so much for that, and I'll see if I can find a way of hosting somewhere this this video recording as well. Okay. Thanks everybody for attending, and that's a wrap. Thanks very much. Catch everybody next time.
Cheers. Bye.
Bye now.